For the second part of the question, they ask us to estimate the norm of f. Whenever we're asked to estimate the norm of something, what they want us to do is to show that that thing that we're estimating, norm of f, is equal to something. We're not asked to show whether it is less than or equal to or greater than or equal to. We want to show that it is equal to something. That's why our final answer here is norm of f equal to this. So just know that whenever you're asked to estimate. So how do we approach this question? We approach by taking the absolute value of this function here. And the function f of x is given to be this. So I take the absolute value of f of x, which is equal to the absolute value of the inner product of x and a plus the inner product of x and b. Due to the linearity of inner product spaces, you agree with me when I say that I can simplify this to be, since x is common to these two spaces, it can be written as, and the operation here is addition. So I can now say that x comma a plus x comma b is equal to x comma a plus b. Yeah, we know that. Then by Cauchy-Schwarz, we know that this is less or equal to the norm of x and norm of a plus b. Also, in that first question that we did as the number one question, we also showed why this is true. So after there, since we've said that this is less or equal to norm of a plus b, and this is equal to f of x, that implies that f of x is also less or equal to norm of a plus b. I'm going to take that again. We showed that x, with the inner product of x comma a plus b, is less or equal to norm of a plus b, and this is f of x. So we're just bringing our f of x back here, which is less or equal to norm of x, norm of a plus b. Now, this entire part here, sometimes people just skip it. So what I'm trying to say is that once you have this, some people have a method where they just cover this x and cover this x and just assume that since we know that the absolute value of f of x is less or equal to the norm of x, norm of a plus b, it implies that norm of f is less or equal to norm of a plus b. So it is fine for you to go from this step to this step, because some people just think that intuitively, if you cover this and if you cover this, then you have this. But what I've done here is explain how we got to that step. So one of the definitions of supremum norm is that norm of f is equal to the sup of f, absolute value of f of x, over norm of x when norm of x is not equal to 0, right? So from here, if I cross multiply, it's going to give me, so my cross multiply, I'm doing like this, cross multiply. So I'm going to have that norm of x is equal to the sup of the absolute value of f of x, which means that f of x is less or equal to norm of f, norm of x. And since f of x is less or equal to norm of x, norm of a plus b here, that implies that norm of f, norm of x is also less or equal to norm of x, norm of a plus b. So since norm of f, norm of x is less or equal to norm of x, norm of a plus b, we can just now divide both sides by norm of x now and just have norm of f to be less or equal to a plus b. So now we've gotten one part of our answer, which is that we know that this norm of f is less or equal to norm of a plus b. So what we now want to do now is show that norm of f can also be greater than or equal to a plus b. Why are we doing that? Because we want to, if we have x less than or equal to y, and then we have x greater than, if we have x greater than or equal to y, and we also have x less than or equal to y, it implies something. It implies that x is only equal to y, because if it's greater than or equal to it, or is less than or equal to it, greater than and less than, they cannot work at the same time. So we can only pick the equal to that is common to the two. So because we want to show that norm of f is equal to something, we would have to show that this norm of f can also be greater than or equal to a plus norm of a plus b. So how do we do that? We take x to be a plus b, and then we replace a plus b wherever we see x in our function. So this is going to become a plus b, comma a plus b, comma b. And linearity, I can take this one, since I can simplify it to become a plus b, comma a plus b. I'm taking the a here plus the b here. This is common to the two. So, and we know that the absolute value of this inner product space is just the square of the norm. So that makes me know that f of a plus b is a norm of a plus b square. And you remember that we said we took x to be a plus b, which means that f of x is norm of a plus b square. Now, this is another definition for supremum norm, which is why I made that video about supremum norm earlier. So we just know how sup works. So here, norm of f is equal to the supremum when norm of x is equal to 1 of absolute value of f of x. And this implies that the absolute value of f of x is less or equal to norm of f. Why do I know that? Because norm of f is the biggest possible value that this could be, because it's the sup, which means that this is definitely going to be less than it, less or equal to it. The highest that it can be is only equal. It cannot be greater than it. So it can be less than it, but it cannot be greater than it, but it can also be equal to it. So from here, I know that this is less than this, which means that this is greater than or equal to this. Since I know that norm of f is greater than or equal to f of x, and f of x is equal to this, that implies that what? It implies that norm of f is greater than or equal to norm of a plus b square. And if norm of f is already greater than or equal to norm of a plus b square, that means it's definitely greater than or equal to the root of it. So I can just lose this square and say that norm of f is greater than or equal to a plus b. Since I've been able to show this, right? And I've also been able to show this. Note that here it is less or equal to it. Here it is greater than or equal to it. The only thing that's going to work for these two is if it's equal to it. So that's why I was able to get to here that norm of f is equal to norm of a plus b. And that way we've been able to estimate the norm of f.